Trevor, thanks for joining us again on the HVAC School podcast.
Thank you so much for having me, Brian, again.
Should I refer to you from now on as Mr. Refrigeration Mentor or something like that? Or
if you want, it's got a good ring coming from your mouth.
Yeah, it is. Yeah, the Refrigeration Mentor. So Trevor is now officially the CEO, founder, president, chief magnate of refrigerationmentor.com, and the site is up. I just took a look at it. It's very nice, really slick. There's some good podcasts up there, so I was glad to see that. Some good quality podcasts on the page.
Yes, there are.
And so it's a great site, and obviously Trevor's doing a lot of mentorship and training in the refrigeration space. We talked about that in a recent episode, but now we're back to the specifics. So today we're going to be covering AE Bulletin 1433, and just give us a quick overview of what that covers, what 1433 is all about.
So we're going to be talking about CS compressors. So these are hermetic reciprocating compressors, and they're starting to run on some of these newer refrigerants like 448, 449, and high glide refrigerants. And I wanted to go through this because I think it's very important what is going on in these bulletins. Not only in Emerson's bulletins, they do a great job laying them out, as well as other manufacturers' bulletins. You need to check and find these compressor manuals. And I thought this was a great one to bring to the podcast to talk about today.
Awesome. Yeah. So specifically this CS compressor, what type of technology is this? What's the application?
So you're going to see it in applications, smaller tonnage, probably, between, it says 1 to 7 horsepower right there in the designations. So you'll be looking up to, how many thousands BTU, depending on what temperature it is, but up to 70, 80,000 BTUs for medium temp, maybe 50 some thousand BTUs for low temp. I'd have to check that in either Copeland Mobile or PSS software, where you'll get even more information involved. And you'll see that they'll do high temp, medium temp, extended medium temp ranges.
Got it. But this is a, so small-ish reciprocating hermetic compressor. So you're not gonna open this bad boy up.
Inside.
Yep, you got pistons inside.
No. Pistons inside.
But very common. I mean, this is a very common compressor that you'll see on a lot of different equipment. And it makes it a great topic to kind of cover here because there is some variability. I mean, these are not exactly the same as scrolls. We talk so much about scrolls, but these actually have some differences here. And right off the bat, it discusses some limitations, some operating envelope things. So you want to start by talking about that?
Yeah, so right off the bat, it talks about, it says approved operation envelopes for figure 4 and figure 8. So that's something that you need to go and look at, the operation envelope of the compressors, because you want to make sure that you don't run outside those envelopes. When you start doing it with any compressor, it starts to cause damage. So you'll see some of them there on page 16, 15. Where that's the operating envelope. That compressor with R22, for example, can go from 0, I'm just looking at Brian's screen, up to 30 degrees Fahrenheit. And then it can go from 90 condensing all the way up to 140. And this is for R22. In that right box, it says 65 degrees return gas. If you're, that's what you want to maintain. That's between 11 degrees Fahrenheit all the way up to 30 degrees Fahrenheit. But if you look at that blue area, say you want to run it at 110 and 5 degrees, 110 condensing, 5 degrees evaporator, you need to have a maximum of 40 degrees, because that suction line definitely needs to be insulated. And we all, in refrigeration, they should be insulated anyway. In any application in air conditioning, they should be insulated. But maximum 40 degrees. If not, just say you're running at that 65 degrees, you're probably going to be overheating that compressor. That's kind of what those blue areas mean.
Exactly. And just, when we say return gas temperature, or RG here, we're talking about our suction line temperature. We're talking about what is the suction line temperature right before it enters that compressor. So right off the bat, we've got some really interesting and very practical numbers that we're looking to hit here. We can see, 65 degree return gas temperature. That's sort of the standard kind of maximum. But then if we were going to run a little lower return gas temperature, then maybe we can run it in a little wider envelope.
And that's going to change depending on the refrigerant as well. So that was just for R22.
Exactly.
When we get down lower, we look at 448, 449, 404, 507, A and F, it's going to be a bit different. But so this is something you need to be aware of. So when you're checking that return gas temperature, you should always be doing this when you're doing troubleshooting of services, always checking that temperature. So if we look on, these compressors are approved to operate down to 70 degrees Fahrenheit. And we just seen with R22, it was only 90. So it depends on the refrigerant again. That discharge line temperature, 225 and 107 C. I kind of like the way Emerson is starting to add new things to their bulletins, just to help technicians understand the difference between Fahrenheit and Celsius, because I think that's something, units are very important as a technician to learn, because you never know what type of equipment you're going to be working on. It could come in bar, especially all these newer equipment coming from Europe, propane, CO2 systems. It's good to understand that, and it's always good to learn more. What the discharge valve backer 275 means, so on that valve plate, you're going to have your valves, and then there's something that you'll see. I don't have a valve plate here to show. I wish I did. There's a backer, so it doesn't really break off that discharge valve, so it'll stop it from breaking or bending. Right. And it's looking, you don't want to go over 275. And then the oil sump 200 and motor winding is 275. And so these are tests that Copeland have done and made sure that it runs in these conditions, to verify that their compressors are going to work for a long time and in good standing.
If I'm understanding this correctly, what they're saying here is that this is how they decided on the envelopes. So they decided on the envelopes in order to make sure that they stayed below these temperatures at these different points in the compressor. Is that correct?
That's exactly right. And if you read the next sentence there, if the system cannot be guaranteeing those guidelines, you need to have a discharge line thermostat 6 inches away, set for 250 on these ones, to protect that compressor, because if you're not keeping those temperatures, you're going to be overheating that compressor.
Yeah. So it's interesting that they give you the envelope, and then they even just they give you a little bit of, I don't want to say wiggle room, but they say, but if you can't now, then do this, which is it's nice. Yeah. I mean, because they recognize not everything's going to be perfect.
Yeah, and I like that too, because it gives a safety for your customer, right? I really believe in systems, especially larger systems, expensive systems, should have these extra safeties. Yeah, we're looking at costs and stuff, but cost doesn't mean anything if it fails in 6 months. Yeah. There's a lot of cost for everyone that end. Yep. So next is superheat. Once again, we talked about this many times. It doesn't matter if it's semi-hermetic, if it's hermetic, if it's a scroll, whatever compressor, 20 degrees superheat, that's what we're kind of looking for. Depending on the application, we're seeing, and I'm seeing more with the new refrigerants like R513. They're saying it's mandatory to have 20 degrees superheat. And if you look at a lot of the compressor manufacturers, the way this refrigerant is made up, that there's potential to dilute before you even hit that 0 degrees superheat. So they're saying on certain refrigerant, newer refrigerant, blended refrigerant, that you have to make sure you have a superheat, a minimum superheat. So something to be aware about new refrigerants.
Yeah, so because in the past when we had, kind of our old school R22s and R12s and all that, we would say, okay, you're not going to have dilution until you hit 0 superheat, until you get a truly flooded condition. But now when you have blends and, the refrigerants just aren't as simple as they used to be, we definitely have to ensure this. And so I want to remind everybody, when we say 20 degrees Fahrenheit superheat, in this context, we're talking about compressor superheat. We're talking about superheat right before it enters the compressor 6 inches from the suction valve. We're not talking about evaporator superheat, because you may have 10 degrees of evaporator superheat, but you're still, in order to get 20 degrees superheat at the compressor, then you would have to pick up an additional 10. If you're not getting that, so say you have very short coupled sort of configuration, then you would need to crank up your evaporator superheat in order to make sure that you are in that safe zone at 20 degrees superheat at your compressor, because it's a protection. You don't want it to be significantly higher than that at the compressor, because it can overheat, and you don't want it to be significantly lower than that, because you can get oil dilution.
Yeah, and that's what we see in the supermarket CO2 systems, where they have to add a heat exchanger in the suction line to bring that superheat up to make sure that you don't go below, say, 20 degrees or 36 degrees Fahrenheit. So I'm sure we're going to see something like that, some sort of designs to help protect systems down the road. We get down to 0.5 suction accumulator. They recommend having a suction accumulator, especially if you have over 6 pound charge in it in the system. And then on systems with defrost harvest during transient operation, they recommend having an accumulator unless you have a suction header that can suffice that volume to prevent any liquid migration. So it's important to understand this is more on the design side. So this will be for the manufacturers who are using these compressors, but it's also so good as a technician to understand this, because we know as technicians, not all equipment works in the lab as it should as in the field, right? So it's something to review and check.
Yeah, and also it's good to understand why some systems have an accumulator and why some don't, right? I mean, that's a question that people ask. Why does this unit have one and why doesn't this one have it? Because they behave differently. I mean, we talk about this a lot when you're charging a system that has an accumulator, especially if you're feeding, liquid into the suction line in real small amounts, kind of, feeding it in real slowly, which is the standard way we charge systems while they're running, recognizing that refrigerant's going into the accumulator and it doesn't make it out into the system as quickly because it's metered through the accumulator. We did a video where we're showing people how to charge, and we realized pretty quickly that we were overcharging the system because we weren't being patient and doing our video. So literally just understanding, what you've got in the system and why it's there is really critical. And in this case, it explains it. When you have more refrigerant, that's a case where you have more likelihood that you're going to have, flood back. You're going to have higher likelihood of off-cycle migration when you have higher refrigerant charges. So just understanding that, I think, is very useful for the tech.
Yeah, exactly. Get down to 0.6 there, liquid line check valve. So it says, with compressors with greater than 6 pounds, check valve is required between the receiver and the condenser. Something that you wouldn't really think of, when you're installing a system to see, is there a check valve in there or not, right? And it says this will reduce liquid refrigerant migration to the compressor during transport and storage. Also down below there, it says energize that crankcase heater 4 hours before initial startup.
Yeah, that's one. That's one that's been on specs for a long time, and I think people have ignored it. But in many cases, especially when you're setting up a new piece of equipment, you could actually go ahead and get that thing powered up, get it running for a while before you start running it. It really is a good practice in order to just prevent initially running that compressor with liquid refrigerant still in the crankcase.
Yeah, no, exactly. 0.7 crankcase heater. So any outdoor system, I say you should have a crankcase heater anytime. And then it says even indoor applications below 40F have a crankcase heater in there, and required on any system with accumulator, because just like you just said there, Brian, that accumulator has a bunch of refrigerant. The system shuts off. Even if it has a pump down cycle in it, there's still refrigerant in that accumulator. If that compressor is colder than the accumulator, where's that refrigerant going to travel, right? So something to be aware of.
Yeah, and this references AE 221182 about liquid refrigerant control. That's a really good bulletin to review, and we've talked about that one in the past.
Okay, well, pump down recommendation. So if short cycling occurs, please check these factors. And this is important. This is like for any pump down system, you need to check this. If you have short cycling issues, you need to correct that problem. You do not let it go. Start it 75 times in an hour, because every time that starts up, that compressor shoots out some oil. It shoots out the oil pump out rate is really high on startups. So you need to understand that system needs to run for some time to get that oil back, right? So it says right here, low pressure sensor, if located right at the inlet of the compressor, will be more sensitive to pressure spikes. For that, may cause short cycling. So you got to think of that. Maybe it has to be moved. Well, it's been there since it was installed. Well, just because it was in there since it's installed doesn't mean it was done correct in the first place, right? So it's something you need to think outside the box sometimes. You need to check your low pressure setting. You need to understand that encapsulated non-adjustable types are more susceptible for short cycling due to tolerance. And then if you cannot stop that short cycling happening, they recommend adding a 5-minute time delay. And I've done that before in the field, and I know many other people have too, because you need to stop the short cycling, because you'll run into lubrication issues.
Yeah, one of the biggest things you see is here it talks about the actual low pressure setting, and number 2 here, you see a lot in refrigeration, people setting up the low pressure setting and pump down just way too low. They don't need to pump down as low as a lot of times people set them up for, and that alone can cause more short cycling.
So if you just want to click on table 3 there, it'll take you right down to the table. And in the table, it says minimum recommended low pressure control settings. And then down below, note, based on 5F outside the lowest point in the evaporator envelope, at sea level. So that means they're saying this, you set it to, for 449, 13 PSIG. That is outside the envelope of the compressor. So you need to understand that too, because you say, oh, well, 13 is the lowest you can go. Well, they're saying you can go 5 out. So because the lowest for 448 is actually 16 PSI. I checked it. That's the envelope. But with low pressure controls for when you're doing pump down or shut off or safety, you can go outside the envelope for a short period of time. You just don't want it to run and run and run and run and run outside the envelope.
Or short cycle outside or do this all the time, short cycling on and off. Yeah.
100%. And that's where you can run into major issues with compressors have an issue, like failing. And there's a warning there. Look, POE may cause allergic skin reaction. People, please use gloves, eye protection. I've got stuff in my eyes, cut my hands, oil in the face before, and it's not fun. I have allergic reactions from it. Right? Yeah. So you need to be safe out there. Your eyes, your ears, your senses, you need to go home to your family at night. Always read the warnings, because I see a lot of people, they just skip the warnings. And I used to too. Don't get me wrong. I used to skip them too, but it's important.
Yep. Yeah, we just had it happen the other day. We had somebody who was brazing, and they weren't wearing their safety glasses, and they somehow got a brazing rod stuck in their eye. It's like that sort of stuff is awful, and it's so easily prevented. I mean, I understand a lot of people, you get busy, you forget, but you really have to prioritize PPE and paying attention to this sort of stuff, because all it takes is one little slip up, and you can potentially lose your sight, or even worse.
Yeah, and that's so important. You want to go to your family home to your family at the end of the day. Just be safe. Take a little longer in the job. Don't worry what your service manager says or what your boss says. They want you to be safe as well. Yes, they want the job done quickly, but if you're hurt and you're off for 2 weeks, you're not out there working either. So they want you to work safe as well. As we go down, just in the lower part there, it says compressor recharge is 4 ounces less than initial charge. So when you look on Copeland Mobile, you'll see initial charge and then recharge. That means that's the service replacement compressor always has less oil. So bill of materials, like with 800 at the end for semi-hermetics, they will have less oil. Scroll compressors, when you go to your wholesaler, your supply house, they're going to have less oil in it, because if you're replacing the compressor, there's oil in the evaporator and the condenser and the accumulator. So there's a reduced charge in those.
That's something I had never heard before, and I've got that question in the past. And of course, that just proves that I haven't read the bulletins as carefully as I should. But that makes perfect sense, and actually is quite thoughtful and quite interesting. So yeah, if the equipment already has oil out in the system, then that manufacturer, when they ship that replacement compressor, is going to ship it with slightly less oil than they would for the OEM application, which is kind of brilliant.
Yeah. And so the practical considerations, I haven't read this one before, but I thought it was pretty cool, and we should talk about it. Like, application restriction imposed on these models may require careful design. So if you look at the first thing, units operating at low evaporated temperature will be susceptible to overheat with dirty condensers and or restricted airflow. Well, we understand that, but with these compressors, it'll be even more. System airflow across the compressor and condenser should be designed to maintain a discharge line temperature below 250. So they want that airflow to go across that. That's so important. This is called, you're cooling that compressor with that air and those condensing units. So it blows that air over it. You'll see it time and time again. Very important that you have that air circulating over there.
Yeah, they're making a really good point here, which is that you may have a piece of equipment that's operating within the envelope when it's brand new. But when you're running a lower evaporator temperature and you get a dirty condenser, what happens to your compression ratio? Well, it increases, right? And it increases more quickly when you have a smaller condenser. So they're kind of suggesting here, based on the sound of it, that in the design considerations, consider putting in a larger condenser so that way you are less susceptible to issues as soon as that condenser starts to foul as well.
Yeah, exactly. Good pickup there,
Yeah.
Brian. Traditional superheat settings, TXE may be too high to maintain return gas temperatures. Well, we talked about that return, that suction gas coming back. If you're in that, we said -5, I think, and 90, you need to have maximum of 40. So you may have to adjust that TX valve. You never want to adjust the TX valve to really maintain the compressor superheat. The whole point of that is to maintain that evaporator.
Yeah.
So if the design is wrong and you have to increase that TX valve, there's something else going on with the system. You need to check suction line sizing, liquid, whatever it is, you need to check. Maybe it's the airflow across the evap coil, I'm not sure. But if you're trying to adjust that compressor superheat and the TX valve, with the TX valve, there's something wrong.
Yeah.
So you need to think about
and
that.
maybe there was even supposed to be a design for liquid to suction heat transfer or something like that in order to get that up. There's some other ways that you can potentially do this in order to keep that compressor superheat and the evaporator superheat where you want. Another thing to keep in mind is that you can only adjust your TX valve so low. I mean, we talked about this, kind of minimum stable superheat. And so if you're in a place where you need to squeeze a couple more degrees lower superheat out of it, you may need to go to an electronic valve in order to accomplish that, or maybe a slightly different TX valve design. So again, that's kind of maybe a little unrealistic or maybe outside of what you'd normally do as a service technician, but just keep in mind that you can only adjust valves so low before they lose control and you start to slam in and out of zero superheat, which then causes flooding. So be careful with that.
Yeah, massive hunting. Yeah. And that's a tip too, like you just said there. If you get a lot of hunting, increase your superheat by 1 degree on your TX valve until to stabilizes out. And point 3, insulate your suction line. That's a minimum. You need to do that all the time. Suction to liquid heat exchanger, like you just mentioned, Brian. Good job. Minimum suction line pressure drop. This is so important. A lot of people don't think about pressure drop, but if you're getting 12 psi pressure drop from the evaporator to the compressor, there's something going on with that suction line. Yeah. You need to figure that out. Is there a filter dryer plugged, an accumulator issue? Is the suction line sized improperly in the first place? Because when you get that pressure drop like that, that compression ratio is skyrocketed, and you're going to fail the compressor quickly.
Yeah. Anything to keep our suction pressure as stable as possible, no pressure drop is ideal. And we talked about this with suction line dryers, how important it is to have minimum pressure drops across those or minimal pressure drops across those. Same thing is true of your suction line. There's nothing good comes of having a suction line pressure drop that isn't there for a reason. And really the only one that is a reason is a suction line filter dryer. And even that should be kept to a bare minimum.
Yeah, and I say remove that. I know it's not practical all the time, but you'll see in this guide it probably says 48 or 72 hours after runtime it should be removed. And it's no different with all the manufacturers. Sporlan says it, Danfoss says it, as well as here's Emerson says it as well. They really should be removed, especially if you get any type of pressure drop across them. I did see older AE bulletins where it says if it's a permanent install, you can have a 3 PSI depending on the refrigerant application, but that's 3 PSI, massive on that compression ratio.
Yeah, it's still costing you. It's costing you in efficiency. It's costing you in compressor longevity by having that pressure drop. So you really want to, again, when you're talking about sizing suction lines, sometimes you have to accept some pressure drop in order to have proper return velocity. So there is a balance there. It's not like you can just infinitely oversize your suction lines. But it should be minimal. I mean, it should be almost immeasurable in most applications, unless you have like a super, super long situation. It's not going to be significant or shouldn't be.
Yeah, and that's something that you should understand is line sizing. I know daily you're doing service, you don't have to size stuff, but I was having a conversation with a manufacturer last week, and he was telling me that one of the engineers at a company said, okay, well, I got a 5/8 liquid line going out to this 1,000 BTU case, and it's not feeding. What's going on? It should be enough liquid at 5/8. Well, really, it probably should have been a 1/4 inch line going out to that case,
Right.
not a 5/8. So because you need to think of that velocity. So I would highly recommend doing a little bit of research if you've never sized before, just to get a better understanding of
Yeah,
it.
yeah. You do not want excessive refrigerant in the system. That's a huge thing when people are sizing liquid lines as well. It's like in order to fill that liquid line, you have to massively, add so much extra refrigerant, which now becomes an issue in the off cycle. So there's just lots of reasons why line sizing matters, and just don't pass over that and think that it's not your job as a service technician when you find something out of the ordinary, because we do. As techs, we find things that are out of the ordinary, and just like we always hear, if you see something, say something.
Yeah, exactly.
Or read something. If you see something, read something more likely.
Yeah. No, that's a really good one. Get into deep vacuum operation here. We should know that you do not want to start a compressor in a deep vac. It's going to arc inside, a high chance of it. I've seen this many times, cutting open these compressors, as well as you want to have a low pressure control on there to protect. You'll see low pressure control is required to protect against deep vacuum operation. So what happens if your system has a leak and you don't have a low pressure control? That compressor is going to just run and run and run and run and run. And over time, as all that refrigerant gets out, now we start reducing, it starts to pull that compressor into a vacuum, which now we have no insulation.
Yep.
Because refrigerant would have been an insulation. And now we get a short. And then you'll see a short, usually right at the fusite, the pins that are coming through the compressor. Yep. That's okay. Compressor cycling, maximum 12 cycles per hour. They'd like to see recommended off time between cycles of 10 seconds minimum. The recommended runtime from startup to shutdown is 5 minutes. It's good to know. Yeah. We talked about short cycling already, right?
It's great, and I love that they give these specific numbers, because the question will come up. Well, how much is too much, right? Well, here it is. This tells you exactly how much is too much, and that doesn't mean that you may not want to even do better than this. But if you're outside of this sort of short cycle envelope, this is a form of an envelope too, right? We want to make sure we don't have more than 12 cycles, and we want our cycles to be 10 seconds minimum and runtime to be 5 minutes. So if we're not operating within that, then it needs to be addressed.
Yeah, exactly. And that's what I like about these manuals. They really give you an idea on what to do, right?
Yep.
Cycle rate. So we talked about this already. Cycle rate also contributes to oil logging. Like I said, if you continue to have short cycling, you can have oil log-in. But here it says, each time the compressor starts, there's a quick reduction in suction pressure and therefore crankcase pressure. The pressure drop causes a reduction in saturating temperature, resulting in oil refrigerant mixture flashing into foam and vapor, with the frequent results that the large percentage of the crankcase oil is pumped out of the compressor. So because that happens, that quick reduction in pressure on that startup, that oil mixture, refrigerant mixture, pumps out even more. So when you see, you can have higher pump out rates. And if this is happening a lot, you're going to get more oil out of that compressor quicker, which is going to cause oil issues. Yep. Right there, 13.2. And are you going to use this stuff every day? No, but the thing is, you can probably use what I've been noticing about learning about compressors. Doesn't matter if it's semi-hermetic, scroll, or hermetic. There is a lot of similarities. Yep. And it doesn't matter what manufacturer it is. You can look at all the big manufacturers. There's so many similarities. If you look at discharge temperature, it's similar. If you look at return gas temperature, it's similar with those refrigerants, right? So when you start getting into the habit of reading these, looking them up, it's going to make your job so much easier.
Yep, for sure.
Starting components, heavy duty type 1. Like they're telling you exactly the type of starting components, because you can go out and buy a start cap that's low duty. They recommend high duty. Have a bleed resistor across there to extend the life of the relay. So what happens if you cut out that resistor, or if you put a start capacitor in with no bleed resistor? What happens? You get sticking relays.
Yep. Which is a major problem. I mean, a sticking potential relay is a major problem, because that results in your start capacitor staying in the circuit, which is going to result in either compressor winding failure, start capacitor failure, or both. So that's the reason why you're going to, if you don't have that resistor, you're going to get these arcs every time, and those arcs are going to eventually lead to contact sticking.
Yeah, and I think there are like 15K ohms, 2 watt resistor, something that you can have in your truck. I didn't always have a heat gun on me when I was in the field, but it's something that over time I work on a lot of electronics now because I work at stuff at home, so I use a heat gun. They're not hard to use and put on there if you needed
Yeah,
to.
good old soldering iron.
Yeah. Yeah, I said heat gun.
Yeah.
Yes, soldering
Yeah,
iron. Thank you.
just
It's a long day already, eh? Insulated terminal connectors to be within the compressor terminal box. You'll see them on the right side there, the molded plug connectors. Motor protection. Internal line brake motor protection is provided in the single phase, and this opens a common connection in the single phase motor at the center of the Y connection of the 3-phase motor. So this is something important to know. So if that internal overload opens, that means your common's open.
Yeah, and in the case of 3-phase, that means you're going to measure open to all 3 terminals. If it's single phase, that means that you're going to read open from start to common and run to common, but you will read the designed, as long as it's working properly, the designed resistance or ohm measurement between run and start. So
Exactly.
That tells you right there, when you have that when you're taking those measurements, you know that it's a thermal overload or motor protector that's open and not a winding issue.
100%. That's a really good point. You should say that again one more time, Brian, because it's important.
Okay. All right. Yeah. So 3-phase, it breaks all 3. So when you have an open motor protection or overload on 3-phase, it breaks all 3. So you're not going to measure. You're going to measure infinite ohms. So when we're saying ohms, we got to distinguish between infinite or open and closed or 0 ohms. And so you're going to read infinite or open in between all 3. So fairly obvious. But if it's single phase, you're going to still measure when you have an open motor protector between start and run, whatever the design resistance is. So you can look at the Copeland mobile app, and it will tell you what the different design resistances are between the terminals. And so that's what it will be, as long as the compressor is working properly within that tolerance. But you will read an open between common and run and common and start, because common is not a winding on a single phase motor. It is just a common connection between start and run. And right behind that common terminal is where they locate that thermal overload or motor protector. And so when that opens, that's how you can, or when you measure it in this way, that's how you can ensure that you know that it is an open internal overload and not an open winding.
Yeah, perfect. Because that I've seen so many in my time when I was with Copeland come back, and they would just start up and we see it was overheating the compressor inside, but for sure they checked that and it was open at the time, didn't let it cool down, and it came back. So, and this happens with a lot of single phase compressors. Internal pressure relief valve, 450 to 550 psi, and when this happens, it results in increased compressor current and protector ambient, which trips off that overload, opens the protector. High pot tests or mega ohm tests, you can check out AE41294. It's once again, I know we've talked about it before. You've talked about it many times. When I was in the field, I didn't do many mega ohm tests, but I've done a lot of them inspecting compressors, doing the high pot test, and it's something to learn as a technician, to understand at least how it works if you ever need to do it, because they highly recommend, all compressor manufacturers, before you deem a compressor fail, you want to check the windings. You want to do mega ohm tests. You want to do all these checks before you say that compressor's failed, because 30% of the compressors that come back to probably all manufacturers, there's nothing wrong with them.
Yeah, if you are going to use a mega ohm meter or a high pot, you just have to really make sure you know how to use it. Because it can easily give you a false positive. So it can make you think that a compressor is bad if it is not bad. And often that happens, especially on scroll compressors, because they measure a pretty low mega ohm measurement. But again, look to the manufacturer's guidelines. In this case, the AE 1294 bulletin is a really great bulletin that kind of addresses this. But really, one of the best uses for high pot and mega ohm testing is to look at winding degradation over time as part of like a maintenance schedule, especially on larger compressors. Most cases, you can use your regular meter, your regular field piece or fluke or whatever you're using, multimeter, in order to do these measurements on the ohm scale and not require mega ohm tester. But sometimes it comes in handy, and I certainly keep one on the truck for those times. But just don't jump in trying to use one and saying compressors are bad without fully understanding the tool.
Yeah, exactly. Because there's lots of them that are like 20 mega ohms, and that compressor is probably still good. It just says, oh, it's red, it's bad. So yeah, understand the tools you're working with. Great point there, Brian. Mounting, they have springs inside them to reduce vibration. These are resilient type mounts and have been developed. So if you ever hear, and I've heard them before, compressor knocking inside one of these spring mounts, so things could happen that they break inside, too much heat. They do have a spring on a lot of them, have some holding force on the top or something to hold them down. So you tip them over, they're not going to fall the springs off. But if someone knocks them over, there's a potential. Pulling plugs, hermetic compressors are pressurized with 7 to 15 psi of dry air before leaving the factory. It should not be open to the atmosphere longer than 5 minutes.
Yeah, that's big.
So that compressor's, well, it's not the compressor, it's the POE oil that's going to start sucking in moisture. And if you're in an area where it's high humidity, probably where you're at, lots of high humidity where you're at, is going to suck as much moisture as possible there. 5 minutes. So you don't pull the plugs off the compressor and then start piping everything up and then pulling the dryers and fit everything first and then start brazing. That the filter dryer and that compressor should be really the last two get the plugs pulled.
Yep. You do not want to expose that to atmosphere and air. If you are going to install them and you're going to do kind of, fitting, dry fitting, then get nitrogen flowing sooner. Get nitrogen flowing to kind of get any air displaced earlier in the process versus leaving it open to atmosphere.
Yes, great point. Pull the larger suction tube. So at the top, we'll see down below, there's going to be 3 plugs. There's going to be the suction, there's going to be the process tube, and then you're going to have the discharge tube. They want you to pull the big suction tube first. We talked about this before on suction. You always want to pull that discharge because it's higher up first, right? In case the lower ones, you'll get oil splashed on it and you got to wipe it off and maybe the silphos doesn't stick. They go through the brazing procedure, flow nitrogen like you just talked about, because if not, it can lead to blockage from that, oxides, copper oxides building up. So 100% do it right. I know I've seen in quite a few groups where people are like, oh, I brazed in systems for 20 years. I've never nitrogen purged. Well, okay, maybe you didn't, but that doesn't mean you're doing it right. And do it right. Take your time, do it right. And it gets quicker and faster. I think the big thing is that, I got to pull up my nitrogen tank. I got to get my gauge up. I got to set this all up. But after you get your process in place, it doesn't take that long.
Yeah, you got to pull your nitrogen out of the truck anyway for pressure testing. So stop acting like it's a big deal. It's just a matter of it's not the way you've done it. And so just get used to doing it that way and you'll be more proud of your work anyway.
Yeah. Make sure you, one side's not evacuated and the brazing torch is then applied. Make sure both sides, high side and low side, you make sure there's no refrigerant there if you're removing the charge. So you got to do both sides because you're not going to pull through that plate just on the suction side.
Yep. And another thing here is talking about unbrazing. In some cases, you don't have a choice but to unsweat. There are some cases where that is the case, and you just have to be really careful about making sure all the pressure is out of the system on both sides. But also, in general, if you can, just cut things out rather than unsweating. It's much safer.
Way safer. Yeah. Way safer. Yeah. Functional check. This 20 service procedure. This is a great section. Check proper voltage. Internal motor protector, is it open or not? Is it short to ground like we just talked about? Allow time to cool to reset. If we go up to number 2, check the compressor is wired correctly. Single phase compressors are so many times not wired correctly. I've seen it so many times come back and the miswiring is right there. You get that back. So it's on there. Take your time, read it, check it, double check the wiring before you turn it on because you can take out that start wiring really quick if you wire it wrong or the potential relay. Verify no system safeties are tripped. Check condenser fan. If the suction falls below normal levels, either it's low on charge or there's a flow blockage. Check compressor current draw compared to Copeland Mobile or they say performance chart. So put it inside Copeland Mobile, get Copeland Mobile out, scan that compressor, and it says, look, plus or minus 15% from published values, a faulty compressor may be indicated.
Yep.
This is make sure that you check the voltage. But one good thing they added voltage there on Copeland Mobile now under the new diagnostics section. So it'll take that into factor as well. Current imbalance exceeding 15% of the average on the three phases of a three-phase compressor should be investigated further. So that's for single-phase compressors, where they'll say if it's 15 plus or minus 15% of the public valve faulty compressor may be indicated. So these are little tips and tricks that you need to understand, and this can go to other compressors as well, because that's 15% would be quite high deviation.
Yeah, for sure.
Before replacing or returning a compressor, check minimum, recheck the compressor for a high pot or a megameter winding resistance and ability to start before returning. Because if you have a humming compressor, it doesn't mean the compressors fail. Oh, I got power to it. I'm checking power, got power to it, but it's humming. Well, it might be that capacitor.
Yeah.
Check the capacitor. It's not giving it that oomph to start up.
Yep. And it could be miswired. It could be the start capacitor, potential relay. It could be the run capacitor. Lots of things that can cause that.
Yeah, exactly. It goes through compressor burn. Majority contaminant will be removed with that compressor. Add 100% activated alumina suction filter dryer. Must be removed after 72 hours. Cleanup procedure. Liquid line filter dryer recommended that the suction accumulator be replaced.
Yeah.
So I know we've talked about this before. Replace that suction accumulator. Yep. On these smaller systems, they're not that expensive. It's expensive to replace a second compressor.
Yeah, for sure.
And then you're replacing the accumulator too on top of that. Startup of newer replacement. No, I put that the blended refrigerant should be charged as a liquid state. So just remember, all these new refrigerants pretty much blends, and you wanna charge them with liquid. And then if you only can get so much in the high side, and you have to start charging in the suction. There's devices that you can buy from different manufacturers that flashes in there, or be really careful adding that liquid and flash it. Make sure you're flashing it into the suction line. Do not operate without enough charge. You need to have at least 7 psi in the suction, because if not, it can lead to early bearing and piston ring failure. So make sure that you're not running it with not enough gas. And you got to charge, you got a good vacuum, you get some liquid in the system, and then make sure you're above 7 psi. Never leave a system with no charge, a holding charge, or service valve closed without securely locking out the system. I think this is a big one where guys, oh, it's just me working on the system, nobody else is here, and all of a sudden you get busy, you go to another site, and somebody else comes and they flick the switch on to just say, oh, it's not running, maybe I'll turn the switch, and then boom, you have a smashed compressor. Make sure you lock that stuff out. Because you were the last one on there. You're the one that shut all the valves, or you left the holding charge in there, or whatever it is. Just do your due diligence.
That's actually a really good point, because we think about lockout, tagout in terms of safety, and that is critical for that purpose. But it's also important to lock out, tag out equipment so that it's not damaged by somebody who comes along and says, "Oh, look, it's just a disconnect that's off." This is a complete diversion. But as we're on the topic of this, I don't know if you saw in social media is going crazy over the recent episode of Grey's Anatomy where where the nurses went up and tried to fix the air conditioner. Did you see this? Okay,
no,
it's all over social media right now, and everybody's yelling at them because you see they open up the unit and the disconnect's off, and they're like, just flip on the disconnect. And I'm thinking to myself, no, don't flip on the disconnect. Somebody probably shut it off because they're servicing something, and now you're going to flip the thing off on and destroy the system. So it's just a funny little side note there.
Or hurt the technician that's on the roof working on it.
Well, no, they're actually on the roof. It's inside of an RTU. They open it up, and there's a nurse there with a giant oversized wrench, about to bang on something, inside the equipment. But it's, one of those silly TV moments that we all like to overanalyze.
Love it. I love it. We get into new installation. I've skipped this so many times, but I think it's pretty important to understand the manufacturers explaining how they'd like you to braze it in. Start with the copper pipe that's in the fitting. So you heat up. So apply heat to area 1, you see there. As it approaches brazing temperature, apply area to the copper pipe as well as the edge of the fitting. And then you rotate it around, make sure you start to heat it up properly, and then you move to the fitting itself. And very minimal time as close to the compressor. Always use, if you can, some sort of heat heat dissipating rags or compound, whatever you guys use, but you don't want to heat up inside that compressor. So I've seen compressors come back where they were heated up so much that you could see that's where it leaked right there, right? Because it was heated too much in those joints.
This is very interesting because this also follows the process that's taught in the Harris Guide. But this, a lot of technicians in the field, a lot of senior techs will not teach it this way. They will teach you to apply it to the female side, heat that up so that way it pulls the solder into the joint. That's the thinking. But the reason why you do it this way is because by first applying heat to the male end and allowing that heat to conduct, it actually conducts more heat into the inside. It's less likely to damage the compressor, but it's also much less likely to damage the copper plating on the stubs.
Exactly.
And that is one of the biggest things that newbie brazers do when they braze in a compressor is they apply too much heat to the female stub. They burn the copper plating off, and now you've got to use a high silver rod with flux, like a 56%, flux coated or something like that in order to get the job done. But most people don't know that, and so they just keep trying to go, and it's steel and it doesn't work and it blobs up and all that. So following this sort of 1, 2, 3, start with the heat further away and then work it in. You have to get everything to that dark cherry in order to pull it into the joint, but you want to keep the heat away from the compressor and allow it to conduct in through the tubing rather than applying it to the outside until the very end.
Exactly. And I never knew this. I didn't know this when I was in the field until I started working on the compressor. So always learning.
Yeah, for sure.
We get down, there's a lot of guides you can go through that we talked about already. 1182, 1105, 1294. We'll just keep going down. Nomenclature is always good to know. You know what I mean? To understand when you get better at it, you can understand capacitor start, capacitor run. Always can pull up Copeland Mobile. They make it Emerson makes it really easy to find that stuff out. And I think there's one more section we probably should talk about. There's a lot of part numbers here. You can get that off Copeland Mobile. You don't need this guide. But if we get down to the operating envelopes, you can see 448, 449, 407A goes from -10 to 30. Don't have any restrictions. 40 degree Fahrenheit return gas temperature. So that's suction line temperature. You can't have 65 in this one like R22. 404 and 507, you can get down all the way to -15 Fahrenheit. But once again, these are refrigerants that you're not going to see on new systems anymore if it's a new system you're building. If we get down to the electrical section, page 18, this is an important section I like to talk about. It's so important to understand what type of compressor you're working on. If you're working on this figure 9, capacitor start, capacitor run, CSCR motor, you want to understand all aspects of it. So on here, you have the start winding, the auxiliary winding, that goes from common to start. That's inside your compressor to start that compressor. Then you have the main winding or the run winding from C to R, which we talked about already. Then you have the potential relay. The potential relay is to really stop that start capacitor after it generates enough voltage. So you take that start winding out like we talked about earlier. We've seen this. You have a failed potential relay, you got to burn start winding. I'm sure you've seen it before, Brian, as well.
Yeah, and this is actually one of my favorite pet topics because a lot of people believe that and this is true in air conditioning, so I'm kind of going to air conditioning real quick because this is where some people learn about this stuff. They believe that putting a start capacitor or a hard start kit, as we call it, on a system that wasn't necessarily designed for it, but as an add-on, that it somehow protects the start winding because it keeps it from getting hot. But actually, it's the exact opposite because your run capacitor acts as a current limiter. It only allows so much current to move in and out of your start winding, which is like you called it the auxiliary winding. That's a really good way of thinking about it. But what the start capacitor and potential relay do is they allow a much larger amount of current to travel through that start winding, but for a very short period of time. I mean, you're really only getting that compressor up to about 80% of its running RPM before the back EMF or the back voltage is great enough. The motor generates its own voltage, is great enough to create a potential between points 2 and points 5, so between common and start, to open up that relay. So that relay starts closed. Once it gets up to that running speed, 75, 80%, then it opens that potential relay and takes that start capacitor out of the circuit. But if you wire it wrong, or if that potential relay fails and that start capacitor stays in the circuit, then that start winding sees high current all the time. and that results in start winding failure or a potentially start capacitor or a potential relay failure, meaning more catastrophic failure. So when you see that, situation where the start capacitor is kind of blown up on you, that's a time to stop and think about, I don't want to necessarily just replace the start capacitor. Let's go ahead and replace the entire gear, the potential relay, and the start capacitor, because it's very possible that constant duty of staying in the circuit is what caused that start capacitor to fail. Because that's they're not designed to stay in the circuit all the time. That's why they look different. They're a different size than run capacitors for the same sort of capacitance rating. So understanding that about them, I think, is very helpful, and often we can prevent problems by, making sure that A, they're wired properly, B, you're not cutting the resistors off of them like we've already talked about, and then not over applying them. If it's necessary for the application, then use them. If it's not, then don't use them unless it's necessary.
Yeah, and that's a good point. Like if you have a start cap fail, just replace all the electrics.
Yeah.
It could be something else that, just like you said. So that's a good point. And so we've talked about it, but the whole purpose of the start capacitor is to boost that starting torque. Yep. And the whole point is to create a magnetic field. So what it does is it shifts or puts out a phase that auxiliary or that start winding compared to the main winding. That's the whole point of the start cap. Yep. And then what the run cap is, it pulls it back into phase so that compressor can continue to run. So just so people know that. And then if we go down a little further, there's a different wiring situations where, you got capacitor start induction run. So CSIR. So now you don't have a run cap here. Once again, you got to wire it up correctly. Figure out what type of system you have. And then you have a permanent split capacitor PSC. So you actually have a PSC resistor between the start and the run.
Yeah. PTC stands for anyone who ever sees these, they can have a lot of different looks to them, but a lot of them are just sort of like this little blue, kind of hard to even describe it, but it's just a little blue cylinder almost. And really all a PTC does is it stands for positive temperature coefficient resistor. It allows for current to move across the line in between start and run, which again allows more current to move through the start winding. It does not create a phase shift, but it does allow more current to move across the start winding. And then what takes it out of the circuit is just it heats up. So positive temperature coefficient just means that as it gets hotter, the resistance increases to the point that it's taken out of the circuit. They are very inexpensive, but they do require some time to reset because they actually have to cool down to reset. And they are kind of prone to failure. I mean, those of us who have worked with a lot of them in the field, because they do generate heat, and that can cause them to fail. So inexpensive, but in essentially every way inferior to the potential relay and start capacitor.
Yes. And I believe you can turn those ones into capacitor start capacitor. One of them you can turn into capacitor start capacitor run.
Yeah, and that's what you would do. Yeah. So with this figure 11, you could change this, just remove the PTC and then wire it up exactly as the CSCR, and that would be functional. So long as you, of course, size the potential relay and start capacitor specific to the compressor. Don't go using something that wasn't designed for that unit.
No, and you can go find that in Copeland Mobile
exactly.
Picture there. So if anyone's looking at this, figure 12, you have the larger ones, the suction, the one besides the process tube, and the one down below would be the discharge. Yeah, the lower one right there. And then you got spacer and mounts. You got to use those ones. And finally is the crankcase heater position, 2 to 2.6 inches. And it shows you exactly where you're supposed to torque that nut, and it tells you what the torque should be. So you should have this close to your discharge line, right where you're tightening it. It shows you exactly where it should be put in, not higher, not lower. And
it's actually fairly important.
Yeah, I like this. Yeah, it's very important, because if you put it too high, you're going to overheat the compressor. If you put it too low, you might have refrigerant in that oil. Yeah. So that's AE 1433. I thought it would be good to talk about it. And these refrigeration compressors CS compressors there's lots of them out there.
Yeah, for sure. We see them all the time. It's a very traditional design that we see with these compressors, and it's good to know all this stuff. It's amazing how much there is to learn, not just about these compressors, but about system design and service broadly. So, yeah, I think this is really great. Thank you for continuing to bring these to us. Obviously, you've moved on in your career to where you're doing your own thing now, but I think this makes a lot of sense. It's going back to the manufacturers, going back to the companies that engineer these products, and just seeing what they have to say, being disciplined enough to actually take some time and go through and read it. And hopefully, for some of us, it is hard to find the time. So that's why we do this, to kind of help guide you through, hold your hand through it. Even if you didn't have a chance to actually see what we're saying, at least you listen to a podcast, you got some ideas, but still ultimately getting the discipline to go back and check it yourself is what we always suggest.
Yeah, for sure. Always try to learn. Take 10 minutes a day if you can. Find some time, because each day will add up. And when you compound that over 2 or 3 years of learning, that's a lot of knowledge that you're going to gain.
For sure. All right, so to wrap up, we want to remind everybody, refrigerationmentor.com. That is Trevor. That is the home of the great Trevor Matthews. So tell us a little bit more about how people can engage with you and maybe what next steps are if they want to receive some training.
Awesome. So yeah, you can reach out to me at refrigerationmentor.com or trevor@refrigerationmentor.com. Reach out to me if you're looking for training. I have 3 courses right now that I'm providing to refrigeration contractors, commercial refrigeration training, basically on supermarket applications, teaching guys how to understand the components, how to do it, troubleshooting. I have a compressor masterclass, really diving deep into understanding, just like we're doing today, understanding compressors, troubleshooting them, services them, and really feeling confident and motivated really to get the job done right the first time. And the other course that I'm offering is a CO2 refrigeration course, because CO2 is coming in every aspect, from commercial refrigeration like supermarkets to heat pumps to small condensing units, and we're going to see more and more of that happening. So I want to help prepare the industry.
Yeah, for sure. Absolutely. That is huge. Actually, I need to get us on board with some of this. We talked about that, but I trust Trevor so much that I'm going to be hiring him to do some training with our team, our grocery refrigeration team, because
Awesome.
we always need more of that. So yeah, thank you, Trevor, for all that you do. Once again, refrigerationmentor.com. Go ahead and blow that site up. Let's see if we can, take the servers down by having so much traffic. We'll have to upgrade his service. That's what we look to do. So,
I love it.
All right. Hey, thank you, brother. We always appreciate you.
Thank you so much, Brian.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.